its core, when we're talking about slope, we're just talking about how steep the line is. And there is a piece included in this, which slope you kind of address how steep the line is, but also whether it's steep going up or down, right, from the left to right. Now, a sport like rock climbing is a sport where slope's pretty important. So let's imagine you're going to a rock climbing trip, or maybe it's like a hiking mixed with rock climbing. So the climbing guide on the trip has placed safety clips in some secure spots along the climb. We start the climb at 0, 0. We end at the point 2019. And there's safety clips at A, B, C, and D. You notice I've already labeled these. You can draw those points on. It's kind of in each like bump, right? A, B, C, and D. So label and start. And then we're going to start out by trying to find what the slope of these sections are. Now, on Friday, on Thursday, you guys dealt a bit with rise and run, right? Rise being the vertical distance between 2 points, run being how far apart they are horizontally. Slope is just going to be those things combined. It's going to be the rise divided by the run. How much up divided by how much sideways. So, taking a look at this Mount Everest ascent, okay, maybe Mount Everest, this is a little bit of a stretch. I suspect that Mount Everest is slightly steeper than this, but whatever. Let's start with this segment going from the start to point A. So the first endpoint is 0, 0. The other endpoint is 5, 5. So the rise in this distance is 5, right? 5 minus 0. The run, the distance sideways, is also 5, 0 to 5. One thing that's a little bit misleading on this graph is you'll notice that it's like each one this way is actually less space than each one this way, right? So it doesn't actually look like it's exactly the same, 5 to 5. It's okay, we can deal with it. So then to find the slope, slope is equal to the rise divided by the run. Rise divided by run. So 5 divided by 5, that's pretty straightforward math equations. 5 divided by 5 is 1. So our slope of this first segment is simply 1. It's a slope of 1. For every 1 that you go up, you move over by 1. All right, next. How about segment A to B? Segment A to B. Well, it goes from 5, 5 to 10, 8. So let's see the rise here. The rise from A to B, it just goes up by 3. Up there by 3. But it's still going over by 5. So it's less steep than the last one. 3 rise over a run of 5. Rise over run, 3 over 5. The slope is 0.6. And you don't have to leave it as a decimal, but usually most of us find it easier to work with decimals than fractions. So I usually prefer if you write it as a decimal, right? In general, 0.6 is kind of a simpler thing for us to deal with than with the fraction 0.5. Would it help if I do with it? I see that there's some straining in the eyes. I'm sorry, I'm kind of famous for my beautiful writing. I hope you'll enjoy it. Is that a little easier to see, but bigger? Okay. I guess I can go even more. Now, I'm going to be kind of moving up and down. You don't actually need the visual, but I find when I'm looking at it, it's kind of like a check. Like when I look, okay, I'm going to do BC next. So looking at this, I can already see BC should be quite a bit steeper than AB was, right? I don't know the exact amount, but I see that it should definitely be steeper. And as I look, it's like, okay, this one's going from 8 up to 14, so that's a rise of 6. And it's going from 10, just over to 14 here, so it's a run of 4. Let's make sure that fits with what's being said here. Oh yeah, 8 to 14 is a rise of 6. 10 to 14 is a run of 4. So our rise over run, 6 over 4, if you calculate that, or if you just reduce the fraction, you end up with 1.5. That's your decimal. So yeah, this was way steeper. It's over double as AB. Okay, next one, CD. C to D. Now maybe once again we can kind of zoom out and just take a look. So CD. Now it looks like it's not very steep. So I'm thinking this is the least steep segment. So let's see if my numbers match that. So the rise ends up being this minus this. The run ends up being this minus this, which is 5. So my rise over run is 2 over 5, or 0.4. Now last one, remember rise is y2 minus y1, or the y value here minus the y value here, it's 3. My run, that's 20 minus 19, that's pretty steep. And taking a look at it, does this seem to match? Oh yeah, I see here that it jumps really quickly from D to E. That last segment is quite steep. So rise over run, 3 over 1. Well, anything divided by 1 is just itself, so this value is 3. All right. So now I'm asked to rank them from easiest to most difficult to climb. Now there's a bit of translation here, right? I'm thinking, okay, easiest to most difficult. Well, what's that saying about slope? The one with the lowest slope should be the easiest to climb. The one with the highest slope should be the hardest to climb. So we're probably just trying to go lowest number up to highest number. Now there'd be a slight trick if one of these was negative. If they were negative, then we'd just be thinking about like the lowest absolute value, the lowest number, not necessarily the. Basically, we're looking at closest to 0 up to furthest from 0. But as it is, they're all positive. Pretty straightforward. Okay, so the easiest is CD with 0.4. Next is AB, that was 0.6. Next is S, start to A. Then we have BC, that was quite steep. But the steepest by far was the summit, DE. It was a slope of 3. Now, one thing that's not accounted for there, I imagine that climbing quite a steep distance would be harder if it's for a longer distance. So I don't know if, DE would actually be harder than BC, because BC you have to go for further. But we're just talking about a steep distance. So the steepest one is DE, even though it's not especially long, right? Good? So far? Make some sense what we're doing? No sense? Just going too crazy? Working? Okay, let's move on, see how this looks. So, slope. Slope is simply a comparison, or ratio, of the vertical change versus the horizontal change in something. Or if we want to get all fancy and physicsy, we could say slope is simply change in y, how high up you're going, over change in x. And you never seen this triangle sign before? Delta? Yeah. Change? It just means a change in something. So it's saying like how different the y values are compared to how different the x values are. And if we want to do this with actual values, we'd say this is y2 minus y1. Right? That's the change in y, y2 minus y1, over the change in x, x2 minus x1. So in a case like this, y2 minus y1 over x2 minus x1 will give us a slope formula. Will tell us what slope is. And slope doesn't have units. We're not talking about like slope as a certain amount of kilometers or something like that. It's just a comparison between two things. It's a comparison between vertical change and horizontal change. And intuitively, most of us get this. If you're talking about anyone in here like snowboarders or skateboarders or anything like that? Oh, that's okay. We got a couple, a smaller number than I thought though. The reality is, you're thinking, okay, do I want to snowboard down this hill, or this hill, or this hill? That's all we're really asking, right? Which one is steeper? Which one are you going to go faster down? Which one's more gradual? That kind of thing. That's kind of all that slope is talking about. Now, another way we can use slope is the same thing as what you guys had thought about last time. We can just instead say it's the rise divided by the run. Right? This and this are talking about the same thing. We would usually use this formula with the y2 minus y1, x2 minus x1. If we're given points, we would usually use rise and run if we're just given what the change is, right? If we already know, oh, this was how much the rise is, this is how much the run is. Now, when you're determining slope, this is that piece from Slope Dude, you always start from the left and work your way to the right. Slope, if it goes up from left to right, is positive. If it goes down from left to right, is negative. If it stays flat, is a slope of 0. And if it is straight up line, then it's undefined. So that's the classification thing. This is, let's just remember our old friend Slope Dude, the Academy Award winning documentary. Uphill, downhill, horizontal, vertical. Cool. All right. Example 1. This line. Positive, negative, 0, undefined. Remember the greatest curse word possible in math and algebra? Undefined! Okay, how about this one? Going up the hill. So what's that tell us from the end value? Positive. By the way, m for slope kind of seems weird. I did look up, I've actually looked up trying to figure out why m is slope a few times. Sounds like it was just randomly called m at some point in like some math class and stuck. A few suggestions are in French, the word for climb is monter, so maybe they thought that was possibly it, but I think it's actually just totally different. The letter M got picked by someone at some point and somehow it just stuck. I have no idea why M would be the letter that's used for slope, but if you ever see M used as a symbol, it's usually talking about the slope of a line. So M is slope, and the reason why, who knows. How about this next one? What's the M value on this one going downhill? Negative. Nice. And this is a bit of a silly question, but this one compared to this one, which one would have a bigger number? Like, which one's value would be higher? Yeah, I think so too. This is steeper. It's down, but the number would be bigger, right? It's a steeper hill. Okay, and how about this last one? It's 0 fun. Although that might be what you're thinking about this class right now. Who knows? All right, slope of these lines. Now here we're going to just take what we've been doing. Now, first of all, I'm going to do this in two different ways. You may find this one of them is sticks for you better. But I'm going to first just do the rise compared to the run. So I'm going to do, on this first one, m equals rise over run. So I'm going to do this by counting rise and by counting run. So this one, the rise is 1, 2, 3, 4, 5, 6, 7. Now, is this one going to be a positive or negative slope? Going downhill, positive or negative slope. Okay, so let's just put that in as a negative right up front so we don't forget it. I find it's not that I always wouldn't know, but sometimes I just forget to put in the thing I didn't know, right? So just remembering, okay, it's negative. And then the run here, I'm just going to count 2, 4, 6, 8, 9. So the slope is negative 7 over 9. And feel free if you want to change that to a decimal. The decimal will be negative 0.7777 reading. That is fine. Alright, so either of these are a fine value for m. So that's if we're just using rise and run. One way of working with this formula. This next one, I'm going to do the same thing, except I'm going to use our other formula, our y2 minus y1 thing. So in this case, I'm going to do m equals y2 minus y1 over x2 minus x1. And this is going to seem like more work up front, because I have to actually figure out what the points are. But stick with me, you might see why we do this. So this point here, this is the point 3, 3. This here is the point negative 3, negative 1. Right, negative 1, 2, 3, negative 1. So if I was just labeling them where their points are, that would be their values. So if I want to sub into this formula, okay, y2, that's this, minus y1, that's this. If you guys want also, I did shower a week or two ago, so I don't smell too bad. Should come up here. Okay, maybe it was this morning. 3 minus negative 1 over x2 minus x1, 3 minus negative 3. So our slope here is 4 over 6. Or if you want to simplify that, 2/3 or 0.6 repeating. That's our slope there, 0.6 repeating. Some of you guys may have just done this by rise over run. So rise would have been 1, 2, 3, 4. Run would have been 1, 2, 3, 4, 5, 6. Right, so 3-way fine. So slope as y2 minus y1 over x2 minus x1, 4 rise over run. Okay, how about C? On C, taking a look here, do I want to do any math, or can I just bail out with something easier? Okay, what can I do? It's a vertical line. What's the end value? line, vertical line. Okay. Similarly for E, anyone want to skip through the math and get out some easy way? What's the slope for E? Horizontal line. 0. This is 0 fun. All right, so just D and F I have left to do. I'd like you guys to try this. Pick some points on D and F and find the slope using them. Pick some points using D and F and find the slope using them. I don't know. So D and F. The trick here is which points should I use? The annoying thing is you can kind of just pick any spots on it, right? If it's actually just a line, the slope will be the same no matter where you're choosing. So I would say go here, go here. The further apart you are, usually the easier you find it. But, oh yeah, that's fine. But frankly, you could have picked here, could have picked here, could have picked here. Any spots like that. Similarly here, let's go this spot, this spot, and that. So find the slope as rise over run. Isaac, you already got it, eh? Yeah, that's what you're doing. I heard the answer is on that ceiling tile. Just look close enough. Oh, you're sharing. Yeah. What do you guys think? All in favor? Opposed? Okay, now, remember last semester I made the use calculation to see how often I studied in the hall? I'm okay with doing that, of course, but I expect you to do next. Okay, set up. Yeah. You, 2 at a time can go, so you do it. So just sign out. You've actually, this is the class that already sent on people, so please just remember there might be other people who need to go use the audience. Thanks. All right, D, what do we get? Rise over run, or did you do? Oh, okay, nice. So you went. This was a 10, and actually relatively easy to see. 5-5, right? So it ends up being 10 over 5 as rise over run, or 2. Nice. Beautiful. I mean, we're not all math geniuses, but good job. Okay, how about this one? How about this one? So this one let's just once again go with our simple rise over run thing. When you can count it this simply, that probably is easier. So the rise here is -4, right? Going down by 4. And the run, 2, 4, 6. Run of 6. So our m value ends up being -2/3 or -0.6 repeating. Either simplest form fraction or decimal are both fine. Yep.
Everything straight is just 0.
If it's a flat line, exactly. That's right. Yeah. Yep. Exactly. And the reason why? What's the rise here? It's nothing. Doesn't go anything.
So now be undefined as well.
No, this is 0. That's a really good question. So for a lot of us, wait, what's the difference between 0 and undefined? Well, 0 is the numerator, the top number, 0 divided by something. And this is like thinking, okay, Isaac and I were having a party last week. We decided to buy 0 pizzas. And we divided these 0 pizzas among everyone who was there. The issue is no matter how many people are there, we still have 0 pizza. Right? 0. Nothing. Too bad. Now, the other thing, this one's a little bit more of a brain bender. It doesn't actually make quite as much sense to us. But okay, what if I instead have, say, 2 pizzas? Or, sorry, 3 pizzas. There's a rise of 3. But we're dividing it among 0 people. Well, if I'm asking you how many pizzas, or how much pizza each person is getting of these 0 people, it's actually kind of a nonsensical question. I'm taking 3 pizzas and dividing them among 0 people. It's an undefined question, right? Well, but it's actually just like an undefined issue. And one more thing, this is a thing sometimes people like seeing, because the reality is it's just a question that doesn't have value, but you can see why it gets there this way. Okay, let's start with this. I was actually really hungry on this imaginary party that Isaac and I didn't have. And first of all, we start with 10 pizzas, and we're going to divide it by 10 people. How many pizzas do we get each?
1.
Wow, that's a good day. Pizza each. Very enjoyable. Okay, but instead, what about this? What about this? I've decided I don't like sharing. So I instead decided no one else gets to be at the party. How many pizzas did I get?
10.
Okay, now this is even better. What if instead I decide to take these 10 pizzas and divided among just 1/10 of a person. I don't know what this means in terms of actual people, but what's 10 divided by 0.1? Yeah, so 10 is 1, now 1 is 10. Okay, so 10 divided by 0.1 is actually 100. And now, don't worry about the story I was telling here. Now we're starting getting into the part where what's 0.1 of a person? Doesn't make too much sense. But let's just see what happens with the numbers here. What if it was instead 10 divided by 0.01? It's getting bigger, right? Now it's 1,000. And you can see how as the number we're dividing by gets smaller, the value gets bigger. So what if instead it was like 10 divided by 0.000000001? Right, some really small number. We get an even bigger number, right? Now we're at like 100 million. And if I instead take 10 divided by actually just 0, now it's undefinable, right? It's actually approaching infinity. Which, in terms of our brain, we're like, wait, what? But anytime we start dealing with infinity, we have troubles. But the point is, when we're dividing by 0, trouble happens because we start dealing with too big of values. Okay, time to move back off my random soapbox and get back into the time. So, what about instead, if we're just having to categorize lines based on what we see of their slope? So we have these 5 lines. A slope of 0.3, positive. A slope of undefined, a slope of negative 2.5, of 0.5, and 0. So first of all, which one falls down as it goes down to the right? One of these ones goes downhill, falls down as it goes to the right. Which one?
Minus 2.5?
Totally. Line 3. Awesome.
I got it from Sierra.
Nice. So you get to share that. I appreciate it. Each of you gets an imaginary candy. Enjoy it.
Wow.
Yeah.
Thank you.
They're the
Imaginary.
they're the special sour ones. Yeah. It's good. One day Mr. Boyce will not be so cheap and we'll get you some treats, but today's not that day. Okay, which one is vertical? Which one's just straight up? Okay, undefined. Okay. Which one is horizontal?
0.5.
Line 5 is 0. Horizontal is the one with the slope of 0.
Oh.
Okay, now which one is the steepest line? Let's go in order. Which one's the steepest? Which one's the vertical cliff, first of all? This is the thing that Isaac likes skiing off of.
Huh?
Right?
Oh, that's what?
Skiing off vertical cliffs?
No. Yeah, it's just really.
So first of all, line 2 is the steepest, the undefined vertical cliff. Okay, okay, which is the next steepest? Or, put another way, which one's the biggest number here?
2.5.
Yeah, exactly. And even though it's negative, it's still the steepest. Because it doesn't matter if a cliff is steep this way or this way. It's still steep. So next should be line 3, the one that's 2.5. Okay, let's just cross them off as we deal with them. Okay, which one's the next steepest? 0.5 is a little steeper, yeah. So line 4 first, then line 1. And then which one's the flattest? Well, the flattest one is the one that's flat. Wow, thank you, Boyce. Really helpful.
Wow.
So
Never do that.
So good. We got it by starting with the steepest one is the steepest one, and the flattest one is the flattest one. Good. We're doing a good exercise in defining our terms. Okay, how about this? Miss Webb's house roof has a rise of 8, thank you, and a run of 8. You guys should get a bonus, hey, if you leave second but you come back first. Should be an advantage. Yes? Yes, I thought that was going to be it. I was hoping for some brilliant mathematical insight, but instead the brilliant mathematical insight was I need to be lucky. Alright, so Miss Webb's house has a rise of 12 and a run of 8. So Webb is rise of 12 over run of 8, or 1.5. Valverde has a rise of 8 and a run of 6. Has 8 over 6, or 1.3. So now, which roof is the steepest? We're just asking which is the biggest number. Well, they're both 1. So we look at the next number. 5 is bigger than 3. So whose roof is steeper? Miss Webb has a steep roof. We built a garage in my house a couple of years ago, and I learned that actually we had to pay slightly more if we wanted a steeper roof. I'm not really sure why, but I went with the less steep roof. Although I've kind of regretted that. Now my roof always has tons of snow on it. But I'm not sure why, but they decided that a more sloped roof is a bit better. probably because it's a little bit easier for maintenance long term.
I feel like it is.
Yeah, I think
If it rains, it doesn't sit just on a flat roof.
you're right. That's a big part of why.
It goes
Exactly.
off.
Yeah, it the grade means that the snow and the rain goes off better. Yeah. The other thing is also it just takes a little bit more material to make it bigger, so that's a big part of the cost. But yeah, in hindsight, I learned yes, people were doing better. Especially I have solar on my garage, so if it was steeper, I actually would have caught a lot more sun too.
You might have to redo it.
The things you learn, no, it's still fine. It's just not as good as it would have been.
Oh.
All right, how about this? This is a bit of an interesting proportions question. Let's just think through what this is even asking. So if a hill has a slope of 9 over 12. So if the hill has a slope of 9 over 12, let's go back to math 10-3 for a second. Remember how in 10-3 there was all that proportion stuff? Like you're setting up the cross multiply divide thing like over and over and over and over and over and over for the whole semester? Well, this might be a similar situation. Has a slope of 9 over 12. Okay, 9 over 12 is the slope. Or sorry, 9 over 20. Only I agree. Now, if I was to write the words again, with slope, what's the top, what's the bottom? Which one's rise, which one's rise?
Is that a 7 or a 1?
Oh, good question. It's neither. It's a 9.
Oh.
And by the way, thank you. If I ever have terrible writing, which might happen once or twice, just tell me, hey, Mr. Boyce, we can't read that. Although also you could have probably tricked you. Okay, never mind. So in slope, which one's rise, which one's rise? Rise, top, over run. So if I'm trying to set up a proportion, it says what is the rise if the run is 15 meters. Okay, so instead, run is 15 meters. We know that's our slope. We're looking for what the rise is. And when we see a proportion set up like this, how do you find the x value again?
Oh, you know, you can do something.
Do something to something else, then something else?
Yeah.
Or more specifically, what Isaac is trying to tell, we just have a real mind link so we know, is the way we find x is we cross multiply divide. What that means is we take the number with it, we multiply across the equals and then divide. Or you could say x is equal to 15 times 9, all divided by 20.
I just said that.
Oh, thank you. Yeah, outstanding. If only the rest of you could have as good of input as Isaac did there.
Exactly.
Okay, 15 times 9 is 135. Divided by 20. You know what I calculated yet? In math class?
I'll give you a Schubert calculator.
Honestly, with you guys, if you take a calculator, just give it back. And I would suggest, please, when you come into class, get the stuff you need to be successful. So if you don't bring a calculator, just come grab one as soon as you come in.
It's not real object.
It's a Cayman, yeah.
Is it real?
Yeah.
So like, I can get.
Pardon me?
Did you like chop that at all?
I did not.
Oh.
A friend of mine's dad was in South America and got that, and then they were moving and he was getting rid of stuff. I said, that looks like it would be a great thing on my desk.
Ooh. Very cool.
So the rise is 6.75 if the run is. Maybe I'll be up front about what I would expect on an exam. This is a word problem, right? It's asking you in words. So probably best would be to say the rise is 6.75 meters. But frankly, I'm generally, as long as you're clear communicating, I'm fine. If you just put what the answer is and box it, I get what you're saying, right? It would be best to answer with words. If you don't and you just are clear with that, that's good. Be clear with what you're trying to answer. Yeah. That's a big part of, if you actually look at the math 20-3 curriculum, it's the same thing with any math course in Alberta. One of the strands of, they call it mathematical reasoning, is communication. I expect to be able to say what you're trying to say. So in this case, make it obvious. What is the rise if the run is this? Boom, you made that clear. Good enough.
So it's 6.75?
Yeah, 6.75 for every 50. Yeah. Okay, have fun with this. A staircase has a slope of 0.75. What is the run if the rise is 2.4, okay? So the slope is 0.75, and that is rise of 2.4 over run of something that I don't know. Okay. So how do I find x? Well, 2.4 times 1 divided by 0.75, cross multiply and divide. X equals 2.4 times 1. I don't really need to probably write the times 1 here. Anything times 1 is itself. Divided by 0.75. x is equal to 3.2.
It equals 3.2.
Isn't that interesting, hey? That when you take 2.4 and divide it by a number that's smaller than 1, it ends up being a bigger value?
Sometimes.
Well, always, if you're dividing by something that's smaller than 1, the value will go up. Okay, with all that said, time for some work. You're going to have more time than you need for this homework. I still think today we're probably only just going to do this lesson. There will be a few days where we go through more than one lesson in the class, but I don't think we need to today. So that means you have 35 minutes worth of time for us to complete the homework, which there's no chance you need. So what I would suggest is do some work, get through it. If you finish, I have cards, a few board games. I'd like to set up a few games so you can kind of learn some games. I also do have Uno cards. But let me know where you need some help. There will be some support that's needed, so let's do that as we're going. Okay, I'll just update attendance.